Sound check 1 2 3. Hi everyone, welcome to PHP Northeast. We've got a great evening lined up for you. Many thanks to our sponsors, Ronald James Group, I Am Property and Opia. If you're looking for a new role, I know that I Am Property is actively hiring, so please check them and the rest of our sponsors out. Tonight we have Michael Peacock speaking to us about infrastructure as code using Packer, Ansible and Terraform. So please bear with me and give Michael a big virtual round of applause as I hand over to him. Thank you.
Hi everybody, thank you very much for coming to my talk this evening. Today I'm here to talk about immutable infrastructure with Packer, Ansible and Terraform. So who am I? I'm Michael Peacock. I'm a consultant CTO and software engineer. I'm the technical director of PackageSpy. We're a software as a service product development company. I'm also the co-founder and CTO of Tutexa. We're a software company for the online tuition business, and I'm one of the co-organisers of PHP Northeast as well. As you can see through the badges I've got at the bottom there, I'm a little bit of a cloud nerd with a number of the AWS certifications as well as Terraform and the very basic Azure and Oracle Cloud certifications as well. So the problem that I want to talk to you about today is if you've got mutable infrastructure. This tends to happen when you've got SSH access to production servers. That allows for system administrators and other people to log into servers. Maybe they'll manually apply some patches or hotfixes that need to be ran. Maybe it's a developer debugging an issue on an application, and as part of that debugging they're realizing that they need to make some live tweaks, so they go in and make a few small changes to that production server, and what you end up with is a lack of confidence on exactly what is running on that production server, because you're now not 100% sure what version of something is, whether there's been any manual tweaks either to the code, to the configuration, maybe there's been some other bits and pieces installed, you're just not 100% sure. In effect, what you end up with is a snowflake server. Martin Fowler's got a good blog post about this, so you can read a little bit more about these. This is where you might have a number of servers or a whole fleet of them that are all meant to be exactly the same, but because they're things that you're deploying to through a non-immutable approach, or because developers have SSH access to go in and debug, there is a risk that these individual servers that should all be the same actually are like snowflakes, and they're all ever so slightly different with their own nuances and quirks, which isn't something that we want. The key message really is that your servers are not pets. We shouldn't be giving them names, we shouldn't be fond of them, we shouldn't show them love. They're not things that we want to keep around forever. We should treat them more like cattle. We don't care what they are. If we need to get rid of them, we get rid of them and we replace them with new servers. We shouldn't be worried about the intricacies of a specific server. You might be asking, is this really still a problem in 2020 with infrastructure as code being as prevalent as it is? The short answer is yes. Even with infrastructure as code, I think there is a real risk that different servers can get into different states. For example, if you're deploying using something like Ansible, Puppet or Chef, where at the time you do the deployment, the server is setting itself up, that could mean if you deploy one server one day and another the next day, it gets a very slightly different upstream dependency because there's maybe been a hotfix to something. So there is a risk that something is ever so slightly different from one version to the other, which you don't have control over because it's being built independently on different days, as opposed to being build the server once and deploy it multiple times. There's also a risk that we could have shadow services running. Maybe a project has suddenly cropped up where you need WebSockets or push notifications, and somebody's thought, I'm just going to go into this machine and I'm going to add socket IO or add something else. So there's a risk that even if your main application is well documented through infrastructure as code, that other things could leak into your infrastructure if you're giving people access to those machines and allowing them to configure them. So with immutable infrastructure, our servers are completely immutable. They're not things that we can log into and change. Any configuration change or code change we need to make cannot be applied to the server itself. It has to be a brand new deployment, which is a new server or a new server image. So this normally means you'll tear down one server, boot up a new one with the new image. That will give you confidence in exactly what's running on those machines, because you know at the point that you built that image exactly what version of something is, what version of the code is, and if you deploy that same image today or tomorrow, it's going to be exactly the same. So I've already mentioned the word image a couple of times there, and that is effectively what this solution is. It's about server images. So when you visit your cloud provider of choice, normally one of the first steps in setting up a new virtual server will be to select an image you want to start with. Maybe Ubuntu or something like that. You'll log into Amazon, DigitalOcean, Linode. You'll say, I want a new server, I want Ubuntu 2020. You're then given a blank machine and you install all of your dependencies on top of it. With this solution, we'll create our own server images with our dependencies and our code already deployed. So we'll start with something like Ubuntu, we'll add our server software, we'll add our application code, and we'll turn that into an image. So if we deploy it today, tomorrow, or next week, we're deploying exactly that same image, so we have confidence that they're exactly the same versions of everything running on those machines. Containers and Kubernetes are also examples of immutable infrastructure, so you may be familiar with it if you're using containers or Kubernetes, as that they tend to be immutable. You do a new deploy, it'll roll out new containers and destroy the existing ones. However, that's not always something that you can use. Maybe you've got something that needs an internal IP address that has to be known to the application. Maybe you've got licensing restrictions, or it's some sort of legacy application where it just can't run within a container environment, but it can run on a virtual machine. So if you can use containers, that's probably a really good approach to use. If you need to use virtual machines for one reason or another, then this approach will allow you to create immutable virtual machines. Why did I use this approach? Mainly because I inherited some off-the-shelf, some enterprise self-hosted software that we needed to run on a particular EC2 instance on Amazon. It had lots of interconnected server software dependencies, so it wasn't just a case of installing a web server, throwing the code up and away it goes. It required lots and lots of interconnected bits of software. There were lots of different configuration files to keep everything running and keeping everything in sync. And some of those had to change quite regularly. So if we added a new authorized domain name to our configuration, we had to go into the server and make a change. And that's something that really I wanted to be able to make as a code change, rebuild that server with all of its intricate dependencies, deploy it, and be confident in what was deployed. It also had license keys. There was a binary server software that had to be installed. It kind of wasn't something where we had access to the code. And there were lots of scripts and cron tabs that all needed to be taken into account. And we also wanted to be able to spin up a second machine if we needed to. So with this being enterprise software running on a machine, if it went wrong or we needed to scale up to multiple machines, I wanted to be sure that we could spin up a new one, plug in the license, and it'd be exactly the same as the other machine, just with the license as the key difference. And all of those bits of software, unfortunately for us, had to run on the same server, so we didn't have much choice as to what we did there. Now, Ansible, Packer, and Terraform, they're all really big topics. They could fill talks in their own right, they could fill large training courses in their own right. So I can't go into a huge amount of detail within this talk, but I can give you a flavour of the technologies on their own, but also how we can use them together to create immutable infrastructure. Okay, so the first one in our list is Ansible. This is infrastructure as code, and it's primarily a provisioner. That means it's going to configure software installed on our servers. And it works really well for the approach of immutable infrastructure because it runs on one machine, such as your local machine, your CI machine or something like that, and then it connects to the machine that's being provisioned. So it's not going to leave artifacts on that server. Unlike things like Puppet, it's not going to poll for new changes. It's up to us to say, we're ready to build a new machine, go connect to it, go configure it. While we can configure the likes of Puppet to be run in a one-off mode where they don't poll, I really like that with Ansible it does leave our provision machines completely clean. So when it's finished, there's nothing on that machine that implies Ansible had anything to do with it. It just connects to a machine, configures it, and then we're ready to create an image that we can use for our infrastructure. So we'll basically use this to, once we have a blank machine, to configure it with our required software. We've then got Packer. This is one of the products from the HashiCorp suite. They're the people that brought us Vagrant. So they've got Packer, they've got Terraform, Console, Vault, and a number of other really great tools. Packer is what we're going to use to create the server images. So Ansible will configure a machine. Packer will then allow us to turn that into a server image without having to do too much work ourselves. And then the final piece is Terraform. Terraform is infrastructure as code, but very much for cloud resources. So with the likes of Ansible, we'll use it to install software. With Terraform, we'll use this to actually say, spin up a server, create a load balancer, create an auto-scaling group, or something like that. Terraform works with multiple cloud providers to provision resources. It's not cloud agnostic, so it doesn't let you spin up an environment on Amazon and then move it to Google Cloud. That's a little bit of a misconception that some people do have with Terraform, because it works with multiple cloud providers. So if you've got your DNS that you're managing through Amazon, you're using Amazon to host your application, but maybe you're using Mailgun for your outbound email or your inbound email, and you may be using Google Cloud for some sort of data warehousing, you could use Terraform to manage all of those resources across all of those different cloud providers. It also supports workspaces, which let you deploy the code to different environments and know which changes need to be applied to which. So you could take the code, deploy it to production, you could have a developer come along and they could deploy it to their own Amazon account, and it'll know that because it's a brand new setup, we need to install all the new servers. Whereas when you come to run the update on a production environment, it knows that everything's already in sync, or we maybe just need to make a small change based off how the code is different from the current infrastructure. So how does this all fit together? Well, what we'll do is we'll create a project with some sample code in that would be our application. We'll use Packer to spin up an Amazon web server, an EC2 instance. We'll use Ansible to provision that instance and install all of our dependencies, install all of our code. Then Packer will finish up by converting that into an image. So it turns the server into an image and it will actually destroy that server. So it only stays around for a few minutes while it does that bit of work. We then have a server image that we can use. In Terraform, we can then say when we want to spin up our application and create new servers, we'll tell it what server image to use. So we can use all of these three things to manage our infrastructure in a very immutable way. I've got a very small sample project that we'll walk through. Basically, it's just going to be a web server with PHP installed, some very minimal PHP code to prove that the server has something configured, and we're going to deploy this to AWS. So firstly, we'll create the image, and then we'll deploy the infrastructure as a server to our Amazon environment. Okay, so we'll start with Ansible so that we can create our code to provision the machine and get everything set up. We can install it through package managers on Linux-based systems, and on macOS we can use pip. It's a Python-based package, so we can use the pip Python package manager to install that. Basic concepts that we need to be aware of with Ansible. It's YAML based, so we just write some YAML code to explain what our server needs to have installed. It's role based, so this works really well if you've got a big fleet of servers that you're managing with Ansible. We're not using it for that, but if we were, we could say we've got thousands of servers. They all need to have a security role. Any of them that are web servers should have the web role applied to them. If they're database servers, they should have a database role applied. And it basically tells it which bits of functionality, which bits of software need to be installed. It also supports clever things like overrides and variables, so you can have modules and roles that have some default configuration but that get overridden when you use them or extend them. It runs sequentially, so unlike things like Puppet, where you've got to worry about dependencies, you basically just put it in an ordered list and say, firstly I'd like you to do an apt-get update, then I'd like you to install Nginx and do all these different things. So we can do it sequentially. And it's got lots of built-in modules for key tasks, so file management, copying files, moving them around, changing the permissions, installing packages, restarting services. There's even modules for working with specific services like Apache or MySQL, so there's sort of common tasks are all built with existing modules, user management, that sort of thing. So we'll use modules to create, to install the key bits of software that we need, package that up into a role, and then we'll use Ansible to apply those rules to those roles to a machine. The Ansible code is then all brought together through a playbook, and the playbook is basically what we want to run on our server. So this is the playbook that I've got for my sample application. I mentioned that Ansible can be used to control a whole fleet of servers, so you can actually segregate this based off different host names and only apply it to certain servers. Here I've just said we're applying this to all of our servers. It's got gather fact set as true. That basically means it's going to gather information about the servers that have been created. So it might find out an IP address or other bits of information. Become, this allows it to deal with privilege escalation, so it can become root as it needs to and manage that seamlessly. And then I've applied two roles, a base role and a web role, and I'll come to those in a second. The structure of these roles, if we look here, I've got my base role, which just has a tasks folder and then a file called main.yaml that basically explains some core functionality that would be applied regardless of the role for this machine. And then I've got a web role where we've got some tasks, so software to install, we've got some files, we've got some defaults, so these are variables that have a default value, and we've got some handlers that basically respond to certain events. And then there's our playbook file that basically says we want to apply both of these roles to our machines. I'll just show you a little bit more about Ansible before we jump into the code and see what I've put together for this sample project. So if we look at the documentation for one of their modules, this is for just a generic package manager. We can see it's quite good documentation that they have. They explain all the different modules, all the requirements. So I can see here that in order to install packages, we're going to need to know what the name of the package is and what state we'd like that package to be in. So do we want it to be installed? So we need to make sure it's present or removed. This basically means that if we want a package to not be there, we can set it to absent, and if it's already there, it will remove it, and if it isn't there, it'll not do anything. It's kind of how we can set that up. And a couple of examples, again, just from that documentation of how we use one of these modules. So we give it a name, so in this case they're saying we want to install nt-update. It's the package module that we're using, what's the name of the package, and what's the state of the package. So that's basically all we need to do in order to install a bit of software. So let's have a quick look through some Ansible code that we can use in this project. So I've got a project here with a provision folder. This is where I've put my Ansible code. We've got two roles, base and web. Under base, I'm just going to do an apt-get update. So there's an apt module that Ansible has, and I'm just saying I'd like you to update the cache, because we don't know how recently built these base Ubuntu images that we're going to start with are. They might be quite old, so we'll do an apt-get update to update the cache. And then I've got my web task where I want to install a web server. I've actually moved this into a variable so that we can swap out between Nginx or Apache if we need to, although I do have some Nginx specific code, so it's not very abstract, but this will pluck from a variable. That's under defaults I've got my variable here, web package nginx, so I can then reference these in my code as web.package. So you can see here web.package, so it knows to pull from that that variable file. So I'm installing the web server, installing PHP. I've got a nginx configuration that's in my files directory, so it'll find nginx.conf in my files directory, and it's going to copy that onto the server as part of the deployment. It's going to start the web server, and then it's going to copy any code that I've got in this HTTP folder. So I've got some application code. It's going to copy those from my machine to the virtual server that we set up, and it's going to put it in the web root. So if I have a quick look in there, I've got an index.php file that's just going to run a little bit of PHP code to check that everything's working. And then we also have a handler. This responds to certain events, so when we install new nginx dependencies or we make changes, we want nginx to update. We can do that using this notify structure. So once we've copied in the new nginx config, we need nginx to restart. So we notify the handler, and it will go and update that. So that's all kind of we need in terms of the very basics of some Ansible code. Obviously this depends entirely on your own application. So the project I mentioned where we had lots and lots of interdependent bits of software, there was an awful lot of Ansible code that we needed to structure that together. But we don't need it for a simple demonstration like this. We just need a little bit to install a couple of key dependencies, copy some code, and we should be good to go. The other nice thing with Ansible here is that I could run this on a local machine, I could run this on a Vagrant environment or a VirtualBox instance, and in theory I can apply the exact same code from my image deployment onto my local machine. Only thing that's likely to be a bit fiddly is that I'm copying application code. On a local machine you'd probably want that to be kept in sync, whereas when you're doing a deploy you're copying the code across. This can also get quite slow if you're copying like a big application, so there's other tricks and tips that you may need to use if you're using Ansible to deploy your code. One instance I've done is actually to have a build script that packages up my code into an archive, copy the archive across, and then I unzip it all through Ansible so it will put it in the right place, move it around, set permissions, rejig configs and so on. But that's all we need in terms of the basic Ansible. And then finally there's our playbook, just to say apply the base role and apply the web role to our applications. Okay, so that's the Ansible side of things. Now we want to apply that to an actual server, and that's where Packer comes in. So Packer is going to allow us to build machine images automatically from our code. Installing it is fairly straightforward. So there's a pre-compiled binary that you just download and add to your path. So on my Mac, I just downloaded it, put it in an appropriate folder that was in my path, and I was good to go. It's also available on Homebrew or Chocolatey, package managers for for Mac and Windows, and it's available through various Linux package managers as well. It's also compilable, it's all written in Go, so you can download the source code and compile it yourself. But in effect, it's one binary, you download it, and you use it. And the way that it works with our application is we create a Packer template that says how we want it to go and create an image, what instructions it should use, how it should authenticate with the likes of Amazon, how it should provision, so whether it should use Ansible or if it should use something else. This is the sample template that's available on the documentation, just so you can see a little bit about how it's structured. The key thing at a minimum is builders. Builders will tell Packer how to spin up a new machine and then convert it to an image. So in this case we know it's an Amazon machine, and it's going to be, this just means it's an elastic block store backed machine image. We tell it how it can authenticate, so in this case we're saying we've got a variable called AWS access key and secret key. We're then telling it that we want it to go and search Amazon's internal list of machine images to find an Ubuntu image. So we're searching for anything by canonical, that's what this owner's attribute is. That's basically Canonical's machine images on Amazon are all given this owner ID. In this case, we're just saying search by this owner ID for anything which name matches this pattern that's for an Elastic Block Store type image. And we've got it set to most recent. This does mean that if you build exactly the same code today versus tomorrow, you may get a different underlying image. It's more secure. But you obviously at least know that because you're running this to build a new image, you are going to get a different image to what you got yesterday. You can change that and make it so it's going to be an exact image, and instead of filtering and searching, you tell it the image to start from. But that's kind of how they start with their documentation. Instance type, so it'll go and create a machine image to do the installation. We normally can just start with a very small machine, so a T2 Micro, one of the cheap free tier eligible machines. It'll spin one up, it'll connect to it, and it will provision it once we tell it to. It also needs to know an SSH username, so it's going to have to SSH to this machine to provision it, so it needs to know what username to use. And then when it's finished, it'll destroy the machine and convert it to an image, and the final bit here is telling it what the AMI name is. So what's going to name that image when it's finished. These two attributes here are being plucked from variables, and you can see the variables are mentioned here at the top. So we've got two variables, and then they're being reused elsewhere in the Packer file. We can pluck those from the environment if we want to. So in most cases, you're not going to want to have your access key and secret in a template like this that potentially would go in version control. So instead, we can pluck that from the environment and say, okay, retrieve these bits of data from the environment, and then we'll use them within our Packer build. So first concept within Packer is the builder, which we kind of walk through the example of here, this one from the template, the Amazon builder. These are what create the machines and generate images, so they're tightly coupled to the cloud provider. And there's lots of different builders available out of the box. We've got AWS, DigitalOcean, Google, Azure, Docker, Alibaba Cloud, Linode, VirtualBox, all sorts of different builders available. And they're purely responsible for creating the machine when it's finished, turning it to an image, closing the machine down. We've then got provisioners. They're the other key concept within Packer. So once the machine is up and running, we invoke a provisioner to do our configuration, to install our software, to copy our code, and do whatever it is we want to turn it from a base Ubuntu image into something ready for our application to be deployed. There's lots of available provisioners, including Ansible, both local and remote, Chef, Puppet, Salt, Shell. There's custom drivers that you can use, and there's other options as well, so there's a number of different provisioners. So for us, in order to provision our Ansible playbook, we need to add to our Packer JSON file a provisioner and say, once you've booted up a machine, we'd like you then to provision it using Ansible, and here's the playbook file. So it'll basically run through our Ansible playbook, connect to that machine, invoke all of the commands, and then when it's finished, it's going to shut that down and save the image. So for us, building this on AWS, this is very similar to what was in the example template. I've just made a few small changes. I've altered the AMI name just so it's a little bit more relevant to us. Instead of using access keys and secrets, I've got a number of access keys and secrets already on my machine, and I'm just telling it I'd like to use the one that I've named PHPNE demo. So instead of having keys that are flying around, I'm just saying, look at this set of keys that I already have on my machine. So we have that. And then at the bottom, we have our provision statement as well. So that makes up our Packer JSON file. And then in terms of building it, there's really two steps. One is we can validate that the file is valid. It'll just check that it's not sort of malformed JSON, that sort of thing. So we can use Packer, validate our JSON file, and then when we're ready, we build using Packer build. So Packer build, we tell it what our file is, and it will go and build our machine. Okay, so let's have a a little walkthrough of both the Packer code and run it and see how that goes. So, mentioned, we've got a Packer JSON file here. I've got my variable, so I'm saying that I want to deploy this into the EU West 2 region, so that's London. I've already got some credentials saved on my machine, so I want to use those. I want to use this region that I've already defined as a variable. I want to use Ubuntu 20.04, T2 micro. I want it to have a particular name, and when it's finished, so that's how it builds, I want to provision using Ansible. So that's all we have there. Okay, so I've got my application here with my Packer JSON file. Packer. So you can see we've got only a few commands here: build, console fix, inspect, validate, and version. So validate Packer JSON. Okay, that hasn't errored, so that means our Packer template should be okay. Now run Packer build. So what this now does is this connects using my Amazon credentials. It's setting up a temporary machine, so there will be a new machine on my Amazon account, but it'll only be there for a few minutes. It connects to it and basically makes it so that it can connect to it, makes it secure and accessible over the internet. It takes a minute or so for that to boot up, and then once it's booted up, it should connect to it and run our Ansible playbook. So just give that a moment. Of course, since it's a live demo, it's taking a little bit longer. It shouldn't take very long. So it's connected, the temporary machine is online, it's running our Ansible playbook. We can see that it's now going through those, so it's gathering facts about the server that's already there. It's done the apt-get, or running the apt-get update. Shouldn't take too long. Then it'll run the other commands, so just give that a moment. Okay, so it's installed the web server, it's now installing PHP. I think the only thing it should have left is then to copy our config and our PHP file. It shouldn't take long. Okay, so yeah, it's installed the web server, installed PHP, copied the Nginx config, it's restarted the web server because we installed some config, it's copied our application code, all of that's succeeded, so we can see there, change 6, nothing, failed, which is great. It's now turning off that machine because we don't actually want it as a machine that exists, we just want the image. Then it's going to convert that into an image. So again, I'm just going to leave that for a few seconds to wait for it to finish. Okay, so it's stopped. It's now telling us that it's creating the image, so we can see there what it's going to be called. So PHP demo and then a timestamp. We can see what the instance was that it was using. We've got an AMI ID, it's just waiting for it to be ready. And then once it's finished, it will actually terminate that instance. So it's not just a case of stopping it, it's actually going to then destroy it. So the only resource we should have left on our Amazon account is the AMI image, which uses a little bit of storage space. So I'll leave that now, and we'll come back to that in a few minutes. Okay, so effectively now we have a Packer image on our Amazon account ready for us to use. So the next stage is for us to look at using Terraform to actually set up servers and deploy that image and use that to create immutable infrastructure. So as I said before, Terraform is very much infrastructure as code, but for your cloud resources. So we can use Terraform to spin up servers, load balancers, manage them, move them around, change them, all that sort of thing. A few high-level concepts about it. It's declarative, so we basically define what we want the infrastructure to be, and then Terraform will ensure that the infrastructure is like that. So with other kind of tools, you might say I want 5 servers, and you run it, it'll give you 5 servers. You run it again, it gives you another 5 servers. With Terraform, you say I want 5 servers, and it will go, you've already got 3, so I'm just going to give you 2 more. It kind of works out the difference between the current state of your environment, what you want it to be, and it transitions to the desired state, which is very similar to how the likes of Kubernetes work. It's all about current state versus desired state and working to get to that desired state. It also works out dependencies itself. So if you've ever used things like Puppet or anything like that in the past, like I have unfortunately, you often had to have dependencies all defined, and you'd say this module depends on this has to run first, even grouping things together. Terraform will work it out. It'll go, okay, you want this server requires a network or requires a security group, therefore I'm going to create those first. And it even has hybrid resources for things that don't exist to deal with things where there might be a little bit of time between a resource becoming available. So it's got all sorts of quite cool things to handle different types of resources. There's a few key requirements to some Terraform code. The first is a provider. So we're basically going to tell it what cloud provider we are working with. For this, it's going to be Amazon, but it can be multiple providers. We could even have multiple of the same provider. So if you've got 2 different Amazon accounts that you're working with, you can actually register multiple of the same provider and basically say spin up this resource in this account, this resource in that account. Variables, we can use those if we've got dynamic data that needs to change on a per environment basis. And then there's the resources themselves. So what resources do we want Terraform to create and manage for us? There's a few key concepts as well that we need to be aware of with Terraform that may be a little bit strange compared to how a few other things work. So providers I've already talked about, but the key thing with Terraform is this thing called a state. So when we run Terraform and say go set up some servers, it will maintain its own knowledge of the state of our environment, and it'll create this state file. It's basically a mapping between the live resource and our code. So if we say we want a server, and we call that server a particular name, it'll know that the deployed server of a particular Amazon ID maps to that server that we've defined. So it's this mapping between what we've defined and what exists, and it uses the difference between the state and our code to work out what it needs to change. So when we do a Terraform deployment, first thing it will do is refresh the state. Are all of the things it thinks are in the state still there? And it'll work out if there's any differences. Then it compares the state to our code and works out what it needs to go and change. The reason that this is a bit of a strange concept is by default the state is stored in our application directory, and it is something you need to kind of share and have access to. So if you've got multiple team members working on it, they all need access to the state, but it isn't versioned in the same sort of traditional sense as your other code. If you switch branches, for example, because you're working on a new feature, the state shouldn't be different because the state represents the exact copy of your live environment now, so it only changes when you change the environment. So it's a little bit of a fiddly thing to have. To solve that, Terraform has got a number of really cool drivers that can store state. So you can just say to Terraform, just store this in the likes of Amazon S3, and it'll store this global file in S3. The other slight challenge is locking. If you've got multiple people running Terraform code on your infrastructure, there's a risk that things could get out of sync. So you really want to lock that file when a deployment's happening. So you can use different tools to lock that state, or alternatively, there's a service called HashiCorp Terraform Cloud, which will allow their cloud version to do the deployments, manage the state, and manage the locking. And there is a free version which is really good, which I would recommend. That also supports remote execution. So by default, you run things and it runs from your machine, and it will then talk to Amazon and set up your servers. You could do that via a CI environment, or if you're using a remote driver for Terraform, then the remote server or provider will do that communication. The code is written in something called HashiCorp language. It's very JSON-esque, but with a few improvements over JSON. They've also got a few slightly strange style guides that they sort of enforce or recommend on your code. And the way that we write these files is we just put them in a folder with a .tf extension, and that's all we need to do. So we can start off with some variables. So similar to what we had in Packer, where we told it about some existing information that may change. So depending on the environment that we're running this in, we might want to change these variables. We can create some variables and say we've got an Amazon region. It's going to run in a US2, so London, and I want to use a particular AWS profile. The nice thing about using these variables is I can define defaults here, but I can also override them when we run Terraform. Also, if we use something like Terraform Cloud, then Terraform Cloud can store those variables, and it can either store them as a regular variable or as a secure variable that you can't read. So you could define access keys and secrets, store them in there, and your developers or DevOps people can write all the Terraform code they want, but without actually having access to the AWS credentials. So we can define some variables, and we'll just put those in a file called vars.tf, so just in a Terraform file. We need to tell Terraform what provider that we're talking to, and for us that's going to be Amazon. So we say we're using the Amazon provider, we tell it the region, and we tell it our credentials. As I'm using a profile, there's a profile option to say use this particular profile. For anybody that knows me, you'll know that I absolutely hate aligning my equal signs. It's something I don't do. The HashiCorp style guidelines basically say if you've got two things at the same level, one line after the other, they want you to align the equals. But if they're not one line after the other, or they're different levels, then you don't worry about it. So just for convention, I have followed their aligned equals, but it's not something I do myself generally. Once we've got that, so we don't really have any proper Terraform code yet, we're just saying we're going to use Amazon and we've got some variables. We then need to initialize Terraform. And what it will do is it will see that we're using Amazon, and it will download the Amazon driver. So because Terraform supports so many different providers, the Terraform binary itself is very lightweight. When you say initialize this project, it will then download some plugins that it needs. Those plugins can be versioned, and they can be different versions for different projects as well. So it'll go and download the appropriate AWS driver for us. So we do that by going into our project folder and running Terraform init. So all this will do is just say we've initialized it and I've downloaded the appropriate driver. So this is the output that we get. It detects that we're looking for AWS, so it goes, gets the plugin, downloads it, and it says our project is ready. It's given us a warning saying you haven't locked the version, you probably should, which is a good point. We probably should think about locking the version. So we've got it installed and initialized, but we don't have any code yet to actually manage our infrastructure. So let's have a look at that. So here's an example resource. This is actually something we are going to use in our demo. I just wanted to walk through one particular example first to explain how Terraform code is structured. So for a resource, they're all defined as these blocks with a resource keyword, so we know it's sort of a thing that it's going to create at a cloud provider level. The next parameter is what that thing is. So this is what we'd look up in the Terraform documentation if we want to know more about this. We'd say, what is an AWS EIP? That's basically an Amazon Elastic IP address. And then this property is a name for us to refer to it as. It's a bit like a variable name. So if we need to refer to it in another resource, we would say, I've got an AWS EIP, it's called EIP for demo, and I need its ID number or some other bit of information. So that's the resource type, that's the resource name. And then you've got key value pairs for all of the attributes that you want to override beyond the default. So in here I'm just saying it's a VPC IP address, so it lives within a VPC. It's not a private IP that I've brought across. And it's got some tags. So within Amazon you can tag everything, give it key value pairs. Here I've given it a name, and it's pulling from one of my variables. So I created a variable earlier called environment name, and it's pulling that variable in, and it's going to use that. And I've said I want it to have an environment tag as well, and that's also pulling in the environment name from the variable. Because this isn't part of a wider string, I don't need to do any string interpolation here. So that's the key bits of a resource. And as I say, we can start linking them together because we know their name, we know their type, and Terraform will deal with all of the dependency resolution and working out what needs to be run first. So let's have a look at some of the Terraform code that I've put together for this project. So we had our provision folder, which had all of our Ansible code, and I've then got a Terraform folder with our Terraform code. So it's got my Terraform state already in here. These aren't things I've checked into version control. I've just kind of ignored those. I've got some variables. So what's the region, EUS2, what profile am I using, an environment name, and when I did this earlier, I created an existing AMI and I got an AMI ID. I'm just going to change that to our brand new AMI ID. So this is the machine image that we've just created. That's the one I'm going to want to use to deploy our code. So these are just some variables. I need this server to be something that we can connect to over the web. So we need to create a security group. So I've created a resource here which is a security group, basically a firewall for servers. I've said it's a web security group that's going to allow inbound traffic on port 80 and 443, and the server is allowed to communicate to the outside world on whatever port it wants. The Terraform documentation is really good, so all you need to do is search for the particular resource that you want. So if I was to say Terraform AWS security group, you'll find out all of the required fields, all of the optional fields. There's normally some examples which tell you certain good approaches that you can use. So here we can see how to structure it, what all the different arguments are. Takes a little bit of time to get used to the different some of the different structures and how some of the dependencies work and a couple of the nuances, but the documentation is very good and very powerful. So yeah, we've got a resource here that defines our firewall. We've already seen our provider resource, just says we're using Amazon, and then I've got a demo file basically saying I'd like an elastic IP address. So we already saw this in our one of the slides. I've got a machine image, so an AWS instance. That's basically an EC2 image. I've called it demo host. It's told which AMI to use, so it's plucking that from a variable, so we can easily change that when we create new images. T2 micro, because I'm a cheapskate. What security group to use, so that security group that we created that only allows inbound traffic on port 80 or 443. I'm saying this server has a number of security groups, so it's a list. You can see that's an array, and we reference them by what is the resource type, AWS security group, what was the name, I called it web security group, and then we need its ID number so we can access resources even though we haven't created them yet. And then I've got some tags. This particular image, I'm just putting in what's known as the default VPC within an Amazon account. The ideal is you would create your own network within your AWS account and set that up, but they're quite cumbersome to set up, and I'm not going to do that with Terraform for the purposes of the demo. So I just want to throw this up and see it work. So that's all the code that we need. Basically an IP address, a security group, a server, and then this final piece here, a binding between the IP address and the server. So if we change the server and it creates a brand new one, it's going to know that it needs to keep that link to that elastic IP address. So we've got that there. So that's our Terraform code. There's not too much to it. We then have two very helpful Terraform commands. The first one is Terraform plan. A little bit like the validate that we had for Packer, except it's a little bit more involved. It basically prepares what Terraform calls an execution plan. It will look at the state, it will refresh it, it will see what resources are going to be created. If it knows more about those resources, it will tell us, and it'll basically say, I'm going to create these 4 things, or 3 or 4 things. here's how they're linked, this is the information I know about them, there's other bits of information that I don't know yet, but I will know once the deployment's happened. But the thing with a plan is it won't actually do anything. It's not going to create resources. It's just telling us what it should do when we run it. So let's give that a run. Check them in the right place. Yeah. Okay, so I can see here at the bottom, the plan has resulted in it's going to add 4 new resources to my Amazon account. It's changing nothing and it's destroying nothing. And if I scroll up, there's a lot of data here, but I can see it's going to create a security group. That's basically the rules we set before. It's creating a EC2 instance. You can see there's lots and lots of properties that we can override here. I've just set them as default, which is why it doesn't know what the answer to these is going to be until it's done its deployment. It's going to associate it with an elastic IP, and it's going to create that IP address. And because we haven't created it yet, it doesn't know what its IP address is, so the public IP is not yet known. So we've got some confidence there that that code is valid and will work. So I'm going to run it, which is the next command. Which is Terraform apply. So that will do a plan, just like we've done before. But it will then ask us, do you want to deploy it? And we've got the option to say yes or no. So it's not going to make the change immediately. We still do have a bit of a get out, but it will will then give us the option of whether we want to actually commit to that and deploy those resources. So Terraform apply. Okay, so do we want to deploy those 4 resources? Yes. Okay, off it goes. You can see it's created a elastic IP address, or it's busy creating it. It does these in parallel, so it tries to create as much as it can as quickly as it can. Creates a security group. While it was doing that, it finished the IP, finished the security group. It's creating my demo host, still creating it. This takes a little bit of time. Finished, and it's associated the IP address. So I've now got a server deployed, I've got an IP address, and I have the server deployed with our application. So I just need to look up what that is, so please bear with me a second. I meant to already have this to hand. I did have it to hand before, but of course when I destroy my resources it gets rid of the IP address, so it's a completely new IP address to what it was using before. Demo server, there we go. IP address. Okay. So it spun up a server for me. This is the IP address that we got, and I can see that it's saying this infrastructure is immutable. So it's running the code that we created as part of that Amazon machine image. So that's all well and good. Next thing is, let's make a small change and see that process end to end of us deploying that infrastructure. While Packer builds, I'll then talk through a couple of the other things, just so we're not hanging around waiting for Packer to do its thing. Just before I do run that again, just to show you, so we've made no changes to our infrastructure, and if I say to Terraform I'd like you to apply again, it should see, first it refreshes the state and checks that all the things it's aware of still exist, and then it goes, no, there's nothing to do, all those things already exist, so that's quite good. Nothing more for it to do. Okay, so our server is immutable. We can't change it unless we change the code and rebuild it. So I'm going to find my code, which is here. I'm just going to change this to very immutable. So we've now got a new bit of code for our Packer image. I'm going to build that. So Packer's going to go away, do its thing. We know that's going to take a couple of minutes. So while it does, I'm just going to skip ahead a couple of slides and walk through those. Okay, so I mentioned that there was a thing called Terraform Cloud. Terraform Cloud just allows us to run Terraform through their cloud services. So instead of me running Terraform Plan or Terraform Apply, I could still do that, but it would actually delegate the work over to their cloud services. The thing that's really nice about that is it links, if you want to, it'll link to your GitHub or other version control. So when you push, Terraform will automatically do a plan, and then you've got the option of going in and applying it and making a note. So it's all audited as to who ran it, who approved it, what happened, and you can see the data history over time. So I can see there's a couple of builds that I ran there. It also allows us to have the environment variables or variables hosted in Terraform Cloud, so they're not shared with colleagues. It keeps track of the current state, so we don't again have this weird state file to share around. And it's got this really cool thing called workspaces. So if we have the same environment and we want to deploy it to a production or staging server, they both need their own state, but they have the exact same bit of code. So we use workspaces to have separate state and variables for the same bit of code. So it's still our master branch of Terraform code, but we're applying it to different environment variables. So that's pretty cool. Just see, that's still doing its thing, so I'll keep going. There's a couple of caveats with immutable infrastructure that are important to be aware of. Things like application logs, user uploads, any database or persistence or cache. Basically anything that you need to think about with most modern projects, whether you're using containers, whether you're using anything where you basically package up the code and throw it at your infrastructure. So often like platform as a service tools, they all tend to work in the same sort of way. Anything with any sort of auto scaling capability is where you shouldn't care about the servers and you shouldn't be naming them or connecting to them. So yeah, we obviously can't rely on those servers being there, because if we do a redeploy, that server's gone and any local logs are gone. So we need to be making sure that we're streaming logs somewhere for developers to access, that user uploads are stored somewhere sensible like S3 or a CDN, and that databases and caches and other persistences are stored using an appropriate service. The other aspect is downtime, which is something to consider. With this particular demo, I've only got one machine that I deploy. So if we redeploy it, which we'll do in a moment, it's going to physically destroy one server and then boot up another. In that gap, there is going to be some downtime. So the ideal would be you have an auto-scaling group of servers, and when you do your deployment, it either adds new ones, then removes the old ones, which you can do with auto-scaling groups, but if you've just got an IP address, it's not quite as easy. It sometimes will switch the IP address before it's ready. Or it might be something where you're removing some servers from the auto-scaling group, but you're still keeping one old one there while new ones are being added. So that's just something you have to be aware of, and it depends on how you're deploying your application. But in this demo, it is a little bit of a problem. Okay, so that's created our machine image. Our deployment is still the same because we haven't redeployed. That's just created a new image. This kind of process of taking the AMID and putting it into Terraform is something we probably want to do as part of a CI process. So we make a code change, we push that, we'd want CI to go and create the Packer image, we'd then want it to say to Terraform, there's a new Packer image, please go and deploy it. But for the moment, I'm just going to go in and plug in our new AMID. So I now want it to do I want to change the deployment. So the first thing the apply will do is it'll do a plan, and what it should realize is that what I've asked for is different to the current state. And you can see here it's going to add 2 new things and remove 2 existing ones. So it's going to remove the server because we've asked it for a brand new image, and by doing that, you can see here Terraform is actually helpfully saying this particular change forces a replacement of the resource. Similarly, we asked it to associate the elastic IP address with a different IP, with a different host, and because the instance ID changes, again, that's forcing replacement of the resource. So yes, that's what we want. And as I say, with this particular approach, there is a small amount of downtime. Terraform has a concept of life cycles, and you can basically say, I actually don't want you to create a new resource, to destroy an old resource until the old one and the new one is in place. So you basically say, if I've got a server and I create a new one, wait until it's ready before taking the old one down. So it does have some provisions. I just haven't got that hooked up with the fact it's just an IP address pointing to a server. So that shouldn't take very long. So I can see that it's destroyed the IP association, it's destroyed the server, so now it's just hanging, there's nothing there. It's now creating the host. I think that only took 20 seconds last time, so I'll give that a few seconds. Okay, so that's finished. That's created the new server. Refresh this. It might be still initializing. Let me see. Yeah, so now the infrastructure is very immutable. So our infrastructure is updated to our new code change. And there's no other way for us to change that server without actually going in and changing the code and doing a build process. One key thing that I intentionally missed out, that I didn't put into my Terraform, is I actually have no SSH credentials for the server, so I haven't told it a key pair. So even if I wanted to, I can't connect to this machine to do anything, so we're completely locked out, which is nice in some ways. And then the final thing, just to show with Terraform, is destroy. So I've got 4 resources in my account that are going to cost me a small amount of money because that account doesn't have a free tier, so that server will cost me. Terraform destroy. That's going to say, okay, for this state, so even if we've got other resources managed in Terraform, this particular state only cares about 4, and it knows that we're going to destroy them. So that's going to go away and destroy those. I'll just leave that. Okay, so in summary, immutable infrastructure gives you the confidence in exactly what you've got running in production. This particular approach lets you build parity between your development and production environments using the exact same Ansible configuration across them both. The shift to immutable infrastructure brings with it quite a few considerations, things like logging, user uploads, and so on, but they're very similar to considerations you're going to have with containers, auto-scaling, and other things anyway. Obviously, this approach only applies to certain use cases. If you're a container shop, then this isn't going to be for you, but if you're already using virtual servers, you're not ready to go into containers yet, but you want to do things a bit more solidly, this is a good approach. If, like me, you've got some legacy enterprise application that's full of all sorts of tightly coupled dependencies, and you want to be able to run it locally, make a configuration change, and know that when you rebuild that, it's going to be a nice gold image that you can deploy. And if you deploy that in a month's time or 2 years' time, it's just going to work. It's not going to have to do another npm install or a composer install and find half the dependencies have disappeared now. It's an image that's already pre-baked and good to go. So that's all from the talk. That's I hope you found that useful, and thanks very much for coming along to attend on a Tuesday evening. I really do appreciate that. And just before I do disappear, just to save getting Nathan back in to thank everyone for coming and to close off the event, just to say once again, thanks for coming. A big thank you to our sponsors. Ronald James Group, one of the Northeast's premier recruitment agencies. They've often got loads of jobs on their site, so do check them out. I Am Property. They're a company based in Gosforth who are actively recruiting for PHP Laravel developer at the moment. So if you're looking for a role, check them out as well. There's Ronald James. And there's Opia as well. They're an agency based up in Gateshead. Lots of blue chip clients. I think they're often hiring back-end devs, DevOps people, front-end developers. So if you're looking for a new role, have a look at all of those sponsors. They're all worth a chat. If you're looking to grow your team, have a chat with Ronald James because they're really well in with the Northeast tech scene. Got lots of developers on their books, so they're definitely worth talking to. So yeah, thanks again for coming once again. Really do appreciate it, and we'll see you next month. Thanks very much. Bye.